Air coolers. Air coolers are the most common type of CPU cooler you'll find inside desktop computers. And for good reason. They're simple, reliable, and they've been doing the job for decades. The cooler sits directly on top of the processor with a chunk of metal called a heatsink. That metal absorbs heat from the CPU, while small tubes known as heat pipes carry the heat upward into a stack of thin fins. A fan then pushes air through those fins, carrying the heat away. It's a straightforward system, but when designed well, it works surprisingly well, even for powerful processors. Stock coolers. Stock coolers are the basic coolers that sometimes come included when you buy a CPU. Think of them as the manufacturer saying, here's something that will get the job done. Most stock coolers use a small circular heatsink with a fan mounted on top. They're designed to handle normal everyday use like browsing the internet, doing schoolwork, or running basic applications. They're easy to install and perfectly fine for casual use, but once the processor starts working harder, they tend to run a little hotter and a little louder. Tower coolers. Tower coolers are what many people upgrade to once they want better cooling performance. Instead of sitting flat like a stock cooler, these stand upright inside the case like a small metal tower. Heat pipes carry warmth from the CPU up into a tall stack of fins, and one or two fans push air through the structure. Because there's more surface area for heat to escape, tower coolers are far more efficient. They've become a favorite in gaming PCs because they deliver strong cooling without the complexity of liquid systems. Low-profile coolers. Low-profile coolers are built for situations where space is limited. In small PC cases, there simply isn't room for a tall tower cooler. So these are designed to stay short and compact while still doing the same basic job. The heatsink spreads out horizontally, and the fan sits close to the motherboard. They won't match the cooling power of larger options, but they make it possible to build powerful, small form-factor computers that still stay within safe temperatures. Dual tower coolers. Dual tower coolers take the tower design and double it. Instead of one stack of cooling fins, there are two large towers connected by several heat pipes. A fan is often placed between them, sometimes with an extra fan on the outside as well. This setup massively increases the amount of metal surface area available to release heat. As a result, dual tower coolers can handle extremely hot CPUs while still remaining quiet, which is why they're often used in high-performance gaming rigs and workstations. Liquid coolers. Liquid coolers approach the cooling problem in a completely different way. Instead of relying on air alone, they use liquid to carry heat away from the CPU. A small pump moves coolant through tubes that connect the processor to a radiator mounted elsewhere in the case. The liquid absorbs heat from the CPU, travels to the radiator, and fans then blow the heat out of the system. Liquids transfer heat very efficiently, which is why these coolers are often able to keep temperatures lower than traditional air coolers. All-in-one liquid coolers. All-in-one liquid coolers, often shortened to AIO coolers, are pre-built liquid cooling systems that come fully sealed from the factory. Everything is already connected: the pump, the tubes, the radiator, and the coolant. The pump sits on the CPU and circulates warm liquid toward the radiator, where fans remove the heat. Because the system is sealed, users don't have to deal with filling coolant or assembling complicated parts. That convenience is a big reason why AIO coolers have become extremely popular in modern gaming PCs. 120mm AIO coolers. 120mm AIO coolers are the smallest common size of liquid cooler. The radiator is designed to hold a single 120mm fan, making it compact enough to fit into many smaller PC cases. While they're not the most powerful option in the liquid cooling world, they still provide decent cooling performance and help move heat away from the CPU more efficiently than many basic air coolers. 240mm AIO coolers. 240mm AIO coolers step things up with a radiator that fits two 120mm fans. That extra length gives the liquid more surface area to release heat, which improves overall cooling performance. For many PC builders, this size hits the sweet spot. It's strong enough for most gaming processors, but still fits comfortably in a wide range of computer cases. 360mm AIO coolers. 360mm AIO coolers are the heavy hitters of the AIO world. Their radiator holds 3 fans, which dramatically increases the cooling surface area. With more airflow and more metal to dissipate heat, these coolers can handle some of the hottest CPUs available today. They're typically used in large cases where space isn't an issue, and maximum cooling is the goal. Custom loop cooling. Custom loop cooling is where things start to feel more like a hobby than just a component upgrade. Instead of a sealed system, the builder assembles the entire cooling loop piece by piece. A pump, reservoir, tubes, radiators, and water blocks are all connected together to form a complete circuit. Coolant flows through the loop, pulling heat from the CPU and sometimes even the graphics card. Custom loops can deliver incredible cooling performance and look visually stunning, but they require patience, planning, and a bit of courage during installation. Passive CPU coolers. Passive CPU coolers take a completely silent approach to cooling. There are no fans spinning and no pumps moving liquid. Instead, they rely on a very large heatsink to slowly spread heat into the surrounding air. Because there are no moving parts, passive coolers operate in total silence. They're usually used with low-power CPUs in quiet systems like home theater PCs or specialized silent builds where eliminating noise is the main goal. If this video somehow cooled your brain more than your CPU, you should probably hit subscribe before your processor starts thermal throttling.